We're here to talk about some of the 10 deadly mistakes that we see over and over again in the Postgres space. And these are things that we asked our service folks, what are you seeing over and over again from a support perspective, from a consulting perspective? What are the common things that people get wrong, and how do they fix them? So to introduce myself, I am the head of open source strategy at Percona. You can find me on Twitter at Yonkovit, and I would appreciate someone taking a photo and tweeting that just so my boss knows that I was here and I'm not at the beach, okay? And you can check out the podcast, The Hoss Talks Foss. You may have heard from some of the speakers who have been on the podcast before. I've had, speakers like Bruce. I've talked with Jonathan Katz before. So if you're interested in things in the open source database space, whether it's Postgres or something else, check it out. So when I sat down and started this presentation, the first thing I did was ask our support team, what kind of issues are we seeing on a regular basis? And so they gave me this handy dandy graph, okay? And what's interesting about this is we see that a lot of issues are really in the config, setup, install, tuning, monitoring, and the HA replication space. You have a little bit of security, a little bit of backup, a little bit of bug crashes. But a lot of times when you think of a support type of an engagement, you're thinking of the software doesn't work. Well, thankfully Postgres is very stable, so there aren't a ton of bugs. But we do see a lot of people who just don't understand the nuances, how to configure, how to tune, how to set these things up. And so this is the overall graph, but I'm going to go through and get a little more specific on these. Okay, and so I'm going to count down David Letterman style. Hopefully people remember David Letterman. I'm old. I remember David Letterman. Maybe some of you do as well. So we're going to start with number 10. Okay. And number 10 is selecting the right tool for the job. Okay. Now, like this gentleman here, I don't think you should use that person as your sawhorse for the saw. You don't want to use tools that are not designed for what you need them for. So, for instance, when you start to look at load balancing or connection pooling, there are several options out there, and understanding the nuances between these is very important. Because if you install and use the wrong tool, you might not get exactly what you're thinking. Okay, so the difference between PG Bouncer, HA Proxy, PG Pool, they do similar things, they just do them a little different. So PG Pool 2, for instance, you're going to get load balancing connection pooling, but it's not as lightweight as the other two. So how you balance this, it's important, and how you set this up, it's just important to realize the nuances between these tools. Another good example of this is PG Repack. How many people have used PG Repack before? Okay, great. So there are locking issues that can occur if you use it. It's a great tool. We highly recommend it. But there are certain operations that will cause slowdowns. So just by deploying the tool, starting to use it, you might run into some problems. So there is a blog post that we did specifically on the things that could go wrong. But you have to watch out, because some of the issues that you might be thinking that you're fixing might actually come back to bite you. Now, the number 9 issue. Now, security was relatively small, but we tend to trust a lot when it comes to the security of our databases, right? Just like this, I love this picture. It is totally secure. You cannot get through my security system, right? But we did a survey the last couple years, and almost 12% of those who responded, these are DBAs, these are developers, SREs, said that they had some sort of database security issue last year. Okay, that's up from 9.5% last year. And a lot of these are misconfigurations. There are things that we have missed. There are things that we could do better. There's other databases that have a more significant security issue than others. For instance, Mongo and Elastic, they don't like you to set default passwords, so a lot of people just leave it open. That's really bad. Don't do that. But when we talk from a Postgres perspective, people not using SSL, for instance, to encrypt traffic, okay? Opening up the Unix sockets, to something that is overly permissive, over-granting permissions, right? Because we all know that when a developer wants access, you just give him everything, and it just works all the time. Using and not understanding the trust reject authentications, and then not auditing things, right? These are all important things that you should consider. Now, as of PG-14, there were some fixes and some enhancements that went in to help with some of the security side of things. I think Jonathan Katz is talking about SCRAM authentication. Doesn't he have a presentation on that this week? I think.
It's complicated. He wasn't here.
Okay. Well, anyways, he has a presentation. There was an introduction to move that as the default authentication system. There's also some new roles that can be used. So as always, as Postgres evolves, some of these issues start to get patched, fixed, made easier for users to use. Okay, now number 8. Any guess what this one's all about, hey? So clean up after yourself. It's right. So I don't know, sometimes my house looks like the hoarder house, but other times it looks nice. I don't know, I don't get it. But it's all about the proper use of vacuum. Everyone's favorite topic. Now there's tons and tons of information about, how you should optimize vacuum. But for those of you who don't know what vacuuming is, it compacts and optimizes the dead space in Postgres. So there are settings that you should be looking at. Auto vacuum is on by default. If you turn it off, there could be some bad things that happen, so you want to be careful of that. But you can tune the vacuum threshold and the scale factor to try and optimize this process. Again, we go back to those tools. PG Repack is a popular tool that many people have used for this. You should check it out if you haven't. And so consider how you're using auto vacuum, because this can cause some issues. Now, if you don't set this up properly, you turn it off, then you end up with, no, that's not a moon, it's your database because of all the space that it has eaten up. Yes. Oh, come on, it's a little Star Wars reference. I even got stickers made. Come to the booth, you can get a sticker. So vacuum enhancements. So there are some things that are improving within Postgres. Obviously, this is 14. I have not looked at 15, but I'm sure that we can get some information on that. But there are some enhancements that have come out to improve performance of the vacuum process. So there's been some tests that suggest up to a 25% improvement on those. And we're also seeing that the vacuum process continues to evolve and get better over time. But if you are not cleaning up after yourself, you're going to have that giant, massive, wasted amount of space, and it is going to slow things down. Now, speaking of slowing things down, how many people have really busy systems? Nobody has really busy systems? Okay, a couple. They don't want to admit it because they're scared, but that's okay. That's okay. Because the other thing that we see that is constantly causing issues is more connections, because we all love to connect to our database even more. There's no such thing as too much of a good thing, right? And so poor connection management leads to quite a bit of problems because of how the connection management and the threading and process within Postgres works. You're going to get potentially lots of duplicated memory, so you're going to consume more memory for every connection. And so as you start to go above 100 connections or more, you're going to want to start to look into load balancing. And if you're not, then you are probably suffering some sort of performance penalty. Again, these things do get better over time, and so we saw in Postgres 14 some of these enhancements helped the throughput and the concurrent workload get better in 14. So these are a little older slides, but you can see that there was some increase in the actual performance at higher connection settings. So again, you want to manage your connections, understand what sort of workload your database has, how things are connecting, what you can do differently. Now, right? I mean, how many people have heard this? Has anybody heard this from like a developer perspective that, they're smarter than me? And so what does everybody do when they hear that or see that? Yeah, no, they're not good enough, are they? No, they're not. So again, if you want a sticker that says this, they're in our booth, so stop by. No, default settings. Okay, so Postgres is awesome. Out of the box, it's tuned for a very generic workload, which means that you need to start to set the parameters that are specific for that workload, right? So effective cache size, shared buffers, work memory, the auto vacuum thresholds. These are things that out of the box, the defaults are not great. They're going to work for a general purpose database. And so you're going to want to look at how to tune and set these out of the box. Similarly, if you start to have a high transaction throughput, you're going to want to look at wall settings to see how fast checkpointing is happening. And you're going to want to look at logging and debugging settings as well, right? So out of the box, hey, it works, that's great, but you're going to leave a lot of performance on the table if you are not tuning. Okay. Number 5, okay? So I don't know, how many people are over people? Anybody? And the rest of you are unders. Okay. Well, so I'm not actually talking about toilet paper. I'm talking about indexing. Yes. Yes. Oh, so I heard that. Oh, yeah. So how many people have ever been in an environment where the developers thought it was a good idea to index every column? By the laughs, I assume that has happened to a few people. Yes, it does. Every index doesn't need a column, or every column doesn't need an index. This is true because guess what? There is overhead to every index you add. And so, the overhead of managing those indexes, maintaining them, every time you update, every time you make changes, it can add up. And so you need to understand that your indexes are there to help with performance, not hinder it. And so if you want to index everything, then maybe you don't really want a relational database. Maybe you want something completely different. But there are specific index types for different types of workloads, okay? How many people are using different index types in Postgres? Oh, not as many as I thought, okay? But I mean, there's the B tree, there's hash, there's gin, there's gist. So depending on what you're trying to do, there's a different type of index that's optimized for that particular workload. See, Postgres gives you a wonderful setup, but you have to know how to tune it and use it to get the most out of it. And if you're not, then you're leaving performance on the table. Now, the good news is, if you are indexing every column, and please don't do that, or even if you're just indexing a few, there has been a lot of work over the last couple of years in reducing the index bloat, right? So we talked about some vacuum changes to help there, but there are also, other things that have been implemented to reduce the amount of bloat that indexes cause and the impact of having too many indexes on the system. So that's good. So, how many people use extensions, by the way? Only a few. Huh. How many people have installed extensions and never used them? Probably way more, because that is another thing that we continually see a lot of, which is, let's just add the extension, we might need it later, okay? Postgres has an awesome ecosystem of hundreds of different extensions that can do all kinds of cool things. But you know what? You implement them and you never use them, and then they just sit there. And so typically what I have heard from our support team is they'll go back and they'll say, well, what extensions are installed? Have you tried turning off the ones you don't need? And a lot of times that fixes problems. And they're just like, yeah, you were using something you didn't need. So the extensibility of Postgres is awesome. But like Spider-Man, with great power comes great responsibility. You need to understand how you are deploying and using your extensions, okay? There are a lot of extensions in the ecosystem that have zero support, which means that if you go download them and use them, they could work or they couldn't work. And whether they work together with other extensions is a potential problem, and it's a rat's nest of issues. So you need to understand where you're getting your extensions. Are they part of the official extensions that are released, or are they just someone who is doing this as a hobby project, and what sort of testing has gone into these extensions? Really, really important for that. Now, with extensions, we've got that, hey, we've never used it, it's there, it's installed, but you know what we never want to use? We never want to use our HA or our backup, right? So a lot of people consider this a secondary issue. It's something that they're sure that they can outrun if they have to. It's going to be something that they can, it'll eventually work out. Maybe you've deployed to the cloud, right? How many people have deployed to the cloud? And how many people have set up HA in the cloud? Hey, how many have set up HA in the cloud correctly? Because here's the fun thing, right? So we, again, back to that survey that we do on a regular basis, 22% of people who responded to the survey said that they had some sort of cloud outage that impacted their databases. Okay, that's a lot. That's one fifth. Okay, that's 1/5 of the people who thought that they were protected and they weren't. And 33% said that they had an issue whether they were running in the cloud or on-prem. So this happens whether you're in the cloud or not. So just because you're using an as a service doesn't necessarily mean that you set it up correctly or that you have taken everything into account. Okay? And as great as Postgres is, it's only great when it's up and running. If it's not running, then you have a completely different problem. And a lot of people are not prepared for that outage. Okay? They're not. And so you have to ask yourself, from an application perspective, how much downtime can you withstand? How much, impact will that have on your business? Do you have an RPO or an RTO? What was the last time you tested your backup and failure? Wait a minute. How many people have tested their backups in the last year? Oh, well, for the rest of you, this one's for you. What did you mean that you never tested your backups? That's right. So that's something that is super critical. And part of this is also understanding, the recovery process and the tools that are out there. I remember I was talking to you a little bit earlier about making sure that you set the correct wall settings. That's going to be critical for, recovery. How are you managing your HA? Are you using tools or are you doing it by hand? It's surprising how many people still think that they can do things by hand. So are you using something like Patroni? Are you using something else? Automated failover is critical. From a backup perspective, how often are you testing them? Are you using tools or just backing up by scripts that you built yourself? PG Backrest is a great tool, right? Are you using it? Have you used it? What sort of retention policy do you have for your backups? Okay, so these are things that you should be asking and understanding, because we all hope there isn't a rainy day, but when there is, you're certainly glad you have the umbrella of the backup. Wow, that was really cliched. I might not use that one again. But, okay, so problem number 2 that we consistently see over and over again is this issue with which workload is the right one to use or to tune, okay? And so, remember I said that Postgres is great out of the box as a very generic setup, but that means that you have to tune it to do what you want for specific workloads. And just because it is battle tested, it's so used, doesn't mean there aren't potential bottlenecks and slowdowns, okay? And so, again, survey data. Woohoo, surveys. I love surveys. So slowdowns and bottlenecks still plague almost 50% of users out there. So, how many people here have experienced a slowdown in production with their database? Oh, how many people are lying about it? Right? It happens over and over again. It's not something that, is solved. And some of this comes down to a couple different things, right? So one is understanding what sort of workload you have. So what tools do you have to look and analyze, the workload that's coming in? Have you considered what your P99 latency is? Anybody familiar with P99 latency? Okay. Well, that is, if you take the 1% outlier, throw it away, what are you looking for in terms of your latency, right? So if this system needs to respond in 10 milliseconds, okay, and we throw away the 1% and it's under 10 milliseconds, that's good. But if it's over, that's bad, right? And so you should be thinking about what sort of response time you have. When your workload does change, do you know? And, here's a classic example, right? There are industries that have a very cyclical business, okay? For instance, accountants. You know what? They're really busy a couple months a year. The rest of the time, they're okay. Right? And so do you understand how your systems are going to be impacted and what sort of changes you're going to see on a monthly or daily basis? Do you have the capability to understand a read-write split? Right? So is this an opportunity to understand Are you writing a lot more data than you're reading? You know, optimizing one for the other is an important thing. And how is this data being used? Is this for every type of, you know, workload, or is it reporting, or is it OLTP, ad hoc? You know, what sort of query workload is going to happen? All of those are really, really important. And you can do this not only for the database, but you can do this for the systems itself, right? So when you look at the systems themselves, you've got things like the kernel parameters, right? So huge pages, swappiness, you know, so you can tune the Linux side of things to make Postgres run faster as well. And so have you done that? Is this something that you've been looking at? Very important that you understand what the workload you're seeing, what your expectations are, and then make adjustments based on that. Now, the number one issue, okay, is this a mistake or is it a feature? Right? So when we talk about where we are spending most of our time from a database administrator or an SRE perspective, what we're seeing is we're spending most of our time in a few key areas, okay? Let's take a look at what the survey says, because I love surveys. So 7% of folks, maybe in this room, spend their time on automation, most of their time on automation. 4%, or I mean, number 4 is 9% moving data between environments. 11% say troubleshooting problems. Number 2, query tuning, 21%. But the number 1 by far is working with developers on their applications. How many people are developers here? Oh, okay. Okay. How many people are developers and DBAs at the same time, and SREs, and everything else under the sun? Okay, there you go. So, you know, when we talk about, you know, working with developers on their applications, understanding the application side, the number 1 issue that plagues most Postgres deployments has nothing to do with Postgres itself. It has everything to do with what we have put inside of Postgres, which is poor database design. Okay, now I have a whole talk on this, so if you're here on Sunday, you can listen to my, you know, lost art of database design talk. But, you know, when we talk about database design, there's a few different aspects to it. Okay, we naturally flow to the schema design, which is an important aspect of this, right? So you want to ensure that your schema is set up correctly, that you have the proper data types set up. You know, for instance, you can use ints or numerics, and do you understand the difference? Some people like to store everything as varchars as opposed to ints. Some people store ints as varchars. There's been a lot of issues that have cropped up from a performance perspective based on the number of data types that you choose. Varchar is probably the most overused data type out there. And part of this is a lot of people like to use ORMs. People using ORMs in here, right? So how many people are using GUIDs, GUIDs, for their primary keys? So are you familiar with that? Okay, it's like an automatic generated primary key. A lot of people do, but that is a really long varchar, right? And it's something that could be replaced with a sequence number or something like that. And every time that you go to access the database by that, that's additional memory that has to be used. That's additional space that's wasted. And so choosing the right data type can not only slim down your database, it can also prevent a myriad of other issues from occurring. So you want to make sure that you're looking at data types as well as schema design. And for those of you who are using ORMs, a lot of ORMs do a good enough job on writing SQL, okay? Which means that they leave a lot to be desired, and there's often a lot of opportunity to tune and optimize those ORMs and the code that it generates in order to get faster running and better performing SQL. This also goes along with designing the systems as well. So, I've been at a lot of places where they'll say, we're in AWS, just get the largest instance size, we'll eventually grow into it. And then I've been at a lot of other places that say, use the smallest instance size until you can prove that you need the bigger one. So you get the extreme opposites of that. but a lot of people will overcomplicate things early on, or they'll not think through the limitations or the potential outcomes in the future. And, this goes hand in hand with not understanding those long-term potential impacts of what you're storing and how you're accessing that data, right? We are digital pack rats now. I don't know if anybody's boss has ever come to them and said, delete that data. Let's get rid of some of that. We have too much data. No, everybody wants more data, and they want to store it for longer amounts of time. And that means that the systems that we're dealing with are getting larger and larger. We just had the talk about the 10 terabytes, was it? 10 terabytes, worth of data. So that's a normal thing now, as opposed to an abnormal thing. So how do we handle that? And can we design around that? Should all that data be in a system that's, handling most of your transactions, or should that be in another database that's for long-term archiving or reporting? Should that be destaged? Should that be archived? Those are the types of questions that often come up. Now, I mentioned, this kind of over-design, and so this is kind of database design, but I called it the bonus section. So, it's the Rube Goldberg effect, right? Anybody familiar with Rube Goldberg? Yes, so let's make the, simple systems as complicated as possible. That's what we want. And we are seeing this, that there is this desire for more, and more, okay? The number of databases being deployed in production is frightening, okay? Not only the sizes, we mentioned the sizes, but when you look at the number of systems, the number of databases in a single environment now, it has grown exponentially. How many people have more than 100 databases in their production, infrastructure? Wow, nobody? Wow. Okay, well, so again, back to our survey here. You look at the data. 40% of those who responded had more than 100 databases that were running in production, and almost 20% had more than 1,000. And this is actually driven by kind of the cloud native microservice movement. Because every microservice wants its own database, right? Every, subcomponent wants its own database. So you take something that, before might have had a centralized database, now all of a sudden we have 15 microservices times that many databases. So now we have 15 databases. Oh, well, we also want replication and we want HA on all those. So now we have 45 databases. Oh, and we're going to archive those. And so now we're up to 60 databases. And it just compiles over and over again. And so that's something that we have to be careful of and watch out for. And, it really has this mentality that, you have to realize that the complex system does not win. So if we're talking winning and losing, you don't get an award for the most complex system, although it is fun to come to conferences and go to the bar and tell everybody how complex your system is. It's a fun after-party activity. So people implement some pretty wild things out there. Not all of them are good. Don't copy them. So that's the 10 most common mistakes that our support and services staff at Percona have seen over and over again. And wow, that only took 30 minutes. So we have plenty of time for questions.